Hi students, once again I welcome you all to my channel Abrar classes. Today we'll be seeing problems on the topic LR circuit that lies in the chapter Electromagnetic Induction. We will see this very first problem. What it is saying, an inductor L, a resistance R, see L is there here, R is there here, and two identical bulbs B1 and B2. Okay, this B1 and B2 are connected to a battery through a switch. Yes, this is a switch. Yes, as shown in the figure. The resistance R is the same as that of the coil that makes L. Okay, this R and let us say an R is there here. Okay, this is same as what this resistance R. Which of the following statement gives the correct description of the happenings when the switch S is closed? Let us say this switch S is closed. Okay, what happens? B1 light up earlier and finally both the bulbs acquire equal brightness. B2, okay, they have given different options. As soon as the switch is closed, as soon as the switch is closed, S is closed here. Okay, what happens? Okay, there will be a current here. I will call this as I1. Okay, this will be current I1 flowing here. I1 will be constant. I1 will be constant here. This I1 is constant because R is connected here, I1 is constant, and that is nothing but what? Now this is E. Okay, this is E here, not B. Okay, this is E. Okay, now if this is E, what is the equation of current? E by R. Okay, this is a battery of EMF E. I1 is equal to constant and that is equal to E by R. Now what happens here? What is the equation of current in case of inductor? Growth equation. Okay, I is equal to I naught into 1 minus e to the power of minus t by tau. Okay, at t is equal to infinity, after some time at t is equal to infinity, what happens? I will be equal to I naught, that is equal to e by r. Okay, e by r. After some time, okay, I will be equal to I naught from here. This I is nothing but same as what? I naught. Okay, I is equal to I naught, and that is, I will call this as I1 because this current is flowing here. This will be same current will be flowing here also after some time. This is also I naught, that is equal to E1 by I1 is equal to E by R. So what happens? B1 light up earlier. Okay, B1 light up earlier. Finally, both the bulbs acquire equal brightness. B2 lights up earlier, and finally B1 shines brighter than B2. The bulb B2 lights up earlier and B1 than B1, and finally both the bulbs shine equally bright. Equally bright. This is the right answer because the current does not change instantaneously in case of inductor. Therefore, what happens? The bulb lights up earlier. Okay, the bulb B2 lights up earlier because I1 is gone. As soon as you close the switch, okay, close the switch, what happens? As soon as you close the switch, I1 is constant, I1 is equal to E1 by E by R. Therefore, bulb B2 lights up earlier than B1. Okay, because it takes time here because the current does not change here. Current does not change instantaneously. Current does not change instantaneously. In case of what? Inductor. Instantaneously. Okay, and that equation is given by what? I is equal to I naught into 1 minus what? E to the power of minus t by tau, where tau is what? Time constant, that is given by L by R. Okay, at t is equal to infinity, if I put infinity here, this will be 0. Okay, this will be 0. 1 minus 0 is I is equal to I naught. Since I have taken this as I1, I am also taking this. The bulb B2 lights up earlier than B1, and finally both the bulbs shine equally bright. This is the right answer. Hope you have understood this one. Now next problem we will see. When a certain circuit consisting of a constant EMF is constant. Okay, EMF is constant. But here the initial slopes are different. See, this is theta 1, I can write, and this is what? Theta 2. This I can write what? Theta 2. Here what is happening? Here tan theta 1 is what? greater than tan theta 2. Okay, tan theta 1 is greater than tan theta 2. We know that what is tan theta 1? Tan theta 1 is nothing but what? E by L1 is greater than what? E by L2. Understood? E gets cancelled, therefore L2 is greater than L1 here. Okay. From this initial slope, we came to know that theta 1 is greater than theta 2, therefore tan theta 1 is greater than tan theta 2. What is tan theta? E by L1, E by L2. Okay, understood. Now, since E is same here, when a certain circuit consisting of a constant EMF E and inductance L and a resistant R is closed, the current in it increases with the time according to the curve 1. Okay, after after one parameter EL or R is changed, the increase in current follows. Okay, which parameter was changed? See here, since the EMF is okay, here see the current here. Okay, current is same. I naught 1 is same as what? I naught 2. Understood? See. Okay, current is same here. I naught 1. What is I naught 1? E1 by R1, that is equal to E2 by R2. Therefore, here E and R are fixed. E and R are fixed. Same value. E and R are fixed. Only one value is changing, and that is nothing but what? Inductance is getting changed. Okay, inductance is increased. In case of 2, inductance is increased. Inductance is increased. See, E1 is equal to E2. Okay, this is R1, this is R2. Okay, this is here E and R are fixed. What is I naught 1? E1 by R1, I naught 2 E2 by R2. Okay, and what is tan theta 1? E by L1, E by L2. Okay, because it is having constant EMF. Okay, E and R are fixed here. Therefore, inductance is getting changed. L is increased in the second case. L is increased. Hope you understood this one. Next problem we will see in the figure shown. You have to calculate the total magnetic energy. Okay, how to calculate the magnetic energy? That is the maximum potential energy is given by what? UL max is equal to half L I naught the whole square. How to calculate I naught here? What is the I naught value of I naught? I naught is equal to E by R. How much is E? 10 divided by R is how much? 2. That is equal to 5 amperes. I naught is 5 amperes here. Therefore, half into L is how much? 2 Henry into I naught is 5 the whole square. 2 gets cancelled. That is 25 joules is the right answer. Hope you understood this one. 25 joules. This is the maximum potential energy. Next problem we'll see. An EMF of 15 volt is applied. Okay, how much? Applied in circuit consisting of what? L and R. This is LR circuit. This is L and this is R, and it is connected to a EMF of 15 volts. Right. L is how much? 5 Henry. R is how much? 10 ohm. Okay. E is equal to how much? 15 volts. The ratio of the current at t is equal to infinity, at t is equal to 1 second. Okay. We have the formula, growth equation of current in case of LR circuit. I is equal to I naught into 1 minus e to the minus t by tau. T by tau. Then what is I naught? I naught is equal to E by R. Okay. I naught is equal to what? E by R. What is tau is equal to? Tau is equal to L by R. How much is L here? L is 5. R is 10. Okay. That is equal to 1 by 2. That is equal to 1 by 2. Now you have to calculate. At t is equal to infinity, what happens? At t is equal to infinity, I will be equal to what? I will be equal to what? I naught. At t is equal to infinity, I will be equal to I naught. Because what happens? See here, I is equal to I naught into 1 minus e to the power minus t by tau. Okay, here if I substitute t is equal to infinity, that is equal to I is equal to I naught into 1 minus e to the power minus infinity. You know what is when e to the power minus infinity is 0, I will be equal to I naught. Now at t is equal to what? 1 second. At t is equal to what? 1 second. What happened? At t is equal to 1 second, I1 will be equal to what? I can write this is I1 is equal to I naught into 1 minus e to the power of minus 1 by tau. Minus 1 by tau. Okay. I am writing at t is equal to infinity, I is equal to I naught. Now you have to calculate the ratio of what? I naught by I1. I naught by I1. I naught by I1 will be equal to, from here we can see, what is I naught by I1? That is equal to 1 divided by 1 minus e to the power of minus 1 by tau. Okay, that is given by 1 divided by 1 minus e to the power of minus, how much is tau? We have calculated. Tau is equal to 1 by 2. Tau is equal to how much? 1 by 2. Therefore, this will be how much? E to the power of minus 2. E to the power of minus 2. What is the answer they have given? They have given. Okay, you have to calculate the, okay, at t to infinity and t to the 1 second. What you have to calculate? You have to calculate the ratio I naught by I1 will be equal to how much? 1 divided by e square minus 1, and here also I can write this as what? E square. E square divided by e square minus 1 is the right answer, because I can write this as what? That is equal to 1 divided by 1 minus e to the power of 2. Take the LCM, you will get this one. Okay, e square divided by e square minus 1 is the right answer. Hope you understood this one. Very easy problem. We'll go to the next problem. An ideal coil of Henry is joined in series. Okay, again you have been given LR circuit. It is connected to a 5 volts battery. L is how much? 10 Henry. Okay, R is how much? 5 ohm. And a battery, okay, E is equal to how many volts? 5 volts. You have to calculate 2 seconds after joining the, we know that I is equal to what? I naught into 1 minus e to the power minus t by tau. T by tau. How much is I naught? I naught is equal to what? I naught is equal to E by R. How much is E? 5 by 5 is equal to 1 ampere. I naught is equal to E by R. I naught is 1 ampere. Now how to calculate tau? Tau is equal to L by R. How much is L? L is 10 divided by 5. Tau is equal to how many seconds? 2 seconds. Now you have to calculate the current at t is equal to 2 seconds. Now from this equation we can write at t is equal to 2 seconds, I at t is equal to 2 seconds, that is equal to I naught into 1 minus e to the power of minus, okay, how much is t? 2 seconds. How much is tau? We got, okay, how much is I naught? I naught is 1. 1 into 1 minus e to the power of minus 1 is the right answer. 1 minus e to the power of minus 1. Okay, 1 minus e to the power of minus 1 is the right answer. Hope you understood this one. We will see the next problem. A coil of self-inductance 5 Henry. Again they have been given LR circuit. Write down the value. How much is E? E is 2 volts. How much is L? 50 Henry. How much is R? R is equal to how much? R is equal to, you are given 10 ohm. Okay, R is equal to 10 ohm. What they are asking? Steady current flows. Steady current means I naught. Okay, how much is I naught? I naught is equal to E by R. I naught is equal to what? E by R. Steady currents, that is nothing but 2 divided by R is how much? 10. Okay, that is equal to 1 by 5 amperes of current is flowing. Okay. If the battery is now disconnected, what happens if the battery is disconnected? This is L, this is R. Battery is what? Disconnected. This battery is disconnected. L is how much? 50 Henry. R is how much? 10 ohm. Okay. So I will be equal to, you are given 1 by E of what? I naught. I will be equal to what? 1 by E. Now here you have to calculate T. At what time this happens. Okay. Now you have to use the equation of what? Decay current. Okay. Not the growth current, decay current is given by I is equal to I naught e to the power of minus T by tau. Okay. You have been given I. I is how much? 1 by E. I naught e to the power of minus T. We do not know. Tau is how much? Tau is equal to L by R. That is equal to L is how much? 50 by 10. Tau is equal to 5 seconds. 5 seconds. That is tau is equal to what? 5. Understood? Now I naught gets cancelled. I can write this as e to the power of minus 1. That is equal to e to the power of what? Minus T by 5. Since the bases are same, I can equate the powers. Minus 1 is equal to minus T by 5. Or T is equal to 5 seconds is the right answer. T is equal to 5 seconds is the right answer. Hope you have understood this one. Okay. For today, I think this much is enough. If you like the video, kindly like it, share it with your friends, subscribe for my channel, and ask doubts in the comment box. Okay, this is part 1 of LR circuit in the chapter Electromagnetic Induction. Hope you understood all these problems. Okay, we have started with this first problem. Okay, what is the equation of growth current? I is equal to I naught into 1 minus e to the power of minus T by tau, where tau is nothing but time constant, that is given by L by R. I naught is given by E by R. That is the maximum current, steady current. Okay, current does not change instantaneously. Therefore, B1 glows after some time after B2. The bulb B2 lights up earlier than B1, and finally both the bulbs shine equally bright. Hope you understood this one. Second problem is very easy. Okay, since you have constant EMF, we know that I naught 1 is equal to I naught 2. E1 by R1 is equal to E2 by R2. E and R are fixed here, and only inductance changes in the second case. Now, in the third problem, this is a direct problem based on the formula. Okay, you have to calculate the magnetic energy stored in the coil, half L I naught square. I naught formula, E by R, that is the maximum current, or that is the current at T is equal to infinity after some time. Okay, that is after a long time, T is equal to infinity. Understood? Now this problem is directly based on this equation. T is equal to infinity and T is equal to 1 second. Just you have to find the ratio. This is also very easy after finding the time constant. Tau is equal to 1 by 2 second. This is okay. T is equal to 1 by 2 second. Understood? Now the last problem is this is also a problem based on this equation. You have to find the current at T is equal to 2 seconds, and then this is the last problem. Here you have to find the value of T. Okay, but you have to use what? Which formula you have to use? This is decay current. You have to use this formula. What is the formula for decay current? I is equal to I naught into e to the power of minus T by tau. What is the formula for growth current? I is equal to I naught into 1 minus e to the power of minus T by tau, where I naught is the maximum current or steady current at T is equal to infinity. That is given by I naught is equal to E by R. And now here tau is nothing but time constant, that is given by L by R. Hope you understood this. Thank you one and all. I wish you all the best.